Recently, Baidu's Ernie-powered PaddleOCR has become the most starred repo on GitHub. So here's the question. OCR isn't new. Why has it suddenly taken off in the past 6 months, with major players jumping in? In this video, we'll break it down. OCR stands for Optical Character Recognition. In simple terms, it means extracting text from images, like copying text from photos in messaging apps. It's not new, but achieving high accuracy is still a real challenge. At a high level, OCR is pretty simple. Given an image, first detect where the text is, then recognize the text itself. You can break it down further, like adding layout analysis before or language correction after, but overall, it's still a two-stage pipeline: detection and recognition. And as you can tell, recognition is both the core and the hardest part. Early systems like Tesseract worked by segmenting characters and matching them to predefined templates. But like many traditional methods, they generalize poorly, struggling with messy handwriting or low-quality images they haven't seen before. Then deep learning came along, and end-to-end transformer-based OCR models emerged, marking the shift from OCR 1.0 to 2.0. Today, multimodal models can perform OCR directly through prompts, extending general vision capabilities into this domain. But in real-world use, problems appear, like imprecise text localization and hallucinations, where the model guesses text that isn't actually there. They're also compute-heavy, making them impractical when resources are tight, creating a gap between capability and real-world needs. Smaller models lack accuracy, while larger ones are too heavy. For a simple OCR task, using massive models feels like overkill, but low accuracy isn't acceptable either. Baidu's PaddleOCR team tackled this with PaddleOCR v5, achieving high accuracy with a lightweight model and breaking this trade-off. On OmniDocBench, PaddleOCR v5 has just 5 million parameters, yet performs on par with billion-scale VLMs and even surpasses them in rotated text scenarios. So how did they do it? In short, don't train a generalist, train a specialist. Instead of only changing architecture, the team focused on data quality, enabling small models to reach state-of-the-art performance. They improved 3 aspects of their data: data difficulty, data accuracy, and data diversity. These charts show how each factor impacts performance. The higher, the better. For data difficulty, harder data improves performance, but only up to a point, a sweet spot where it's just right. For data accuracy, the model is quite robust to noisy labels, meaning slightly imperfect data doesn't impact it much, so you can trade a little precision for a lot more data. For data diversity, more varied data clearly leads to better results. Diversity matters more than sheer volume of similar samples. And of course, more data still helps. No surprise there. So how did they do it? First, they used a preliminary model to score samples by confidence. High scores mean easy, low scores mean hard or mislabeled. The best data lies in the middle, the sweet spot. For data accuracy, they ran a noise experiment, randomly corrupting labels in a clean dataset to measure performance drop, answering how much noise the data can tolerate before performance starts to drop off. For data diversity, they clustered images into visual categories, like signs, labels, handwriting, and varied category coverage while keeping data size fixed, measuring gains in generalization. So PaddleOCR didn't just build a strong, small model, one that acts as the eyes of large models, accurately extracting text so their reasoning starts from a correct foundation. It also introduced a practical method for selecting high-quality data, proving the effectiveness of a data-centric approach. And the impact goes well beyond OCR. Huge amounts of real-world data, receipts, contracts, chats, screenshots, remain underutilized. Once OCR becomes accurate and affordable enough, all of this data can be structured at scale and turned into high-quality training data. At that point, how far models can go may depend only on our imagination.